Welcome everyone to this Self-Help Africa Science for Development webinar focusing on global soil. Each webinar of this series showcases student research projects that were part of the 2024 BT Young Scientists competition. And also we always feature a field scientist who joins us from one of our program countries. So today we are going to hear from our office in Kenya in East Africa. My name is Aaron Towers and I'm part of the Global Citizenship Education team at Self-Help Africa here in Ireland. And each year we have the pleasure of participating at the Young Scientist in Dublin and presenting our Science for Development Award. Our particular interest, because we're a development organization which works primarily with smallholder farmers, is we look for projects that research and suggest innovations that look to address poverty and climate injustice. Any suggested solutions, therefore, need to be accessible for all, they need to be climate smart, and they need to address issues faced by rural farming communities, particularly such communities in Africa. These are communities which Self-Help Africa works with as part of Irish Aid's programme for sustainable development. Looking at today's focus on soil, when you consider agriculture and food production, nothing could really, I think, could be more fundamental than soil and soil health. But unfortunately, soil health is often neglected, even though 99% of our food production relies on it. Good soil is easily lost and takes a long time to replace. I thought to mention, if anyone is looking to, dig deeper into this topic, I would strongly recommend the work of the UK journalist George Monbiot, and in particular his book Regenesis, which is quite a remarkable publication, covering all things to do with soil and new approaches to reimagining agriculture. So, and he's publicized a lot in a lot of papers, does a lot of climate action, climate justice type articles. So today's panel, can I introduce, we have at the moment a student from joining us from Cork, Nikhil. You're very welcome. We're going to hear about his research into potato blight. And then joining us from Nairobi, Kenya is Self-Help Africa's Natural Resource and Forestry Advisor, Ruth Mukhongo, and you are both most welcome. So Ruth, as way of introductions, I noticed in your bio that you have a PhD. That makes you or I've come up with the title that you're a doctor of soil. You know soil very well. Your PhD is in soil science. Part of this webinar series is to inspire agricultural and development sciences or scientists of the future. I wonder, could you give us a little background of how you ended up with a PhD in soil?
Thank you, Aaron. Yes, my name is Ruth Mukhongo. Yes, I have a PhD in soil science. And before achieving the PhD, of course, I started off from the village. I grew up in the village in a farming household. As much as my dad was a teacher and my mother was a businesswoman, we practiced peasant farming to some extent. And through this experience or exposure, I learned that agriculture is the backbone of our economy, first of all. And secondly, agriculture is a source of food and nutrition security and even income security. And so when I continued with my studies, I pursued agriculture both at primary school and secondary or high school level. And again, before I finished my last practical agriculture paper at high school level, I had that interest of pursuing an agriculture-related course in college, that is at the university level. So I had 4 choices, and there was follows. The first choice was nursing. The second choice was horticulture. The third choice was education science. And the fourth choice was special education. When the results came out, my dad wasn't comfortable with me pursuing an agriculture-related course. So he tried to convince me to go change and pursue education science. But I tried, I couldn't manage. The class was already full. So I was encouraged by both my sisters and brothers just to pursue the horticulture course. So I pursued Bachelor of Science in horticulture at undergraduate level. And as I was drawing closer to the finish line, I met a encouraging professor in soil science. He comes from northeastern Uganda, Professor Kalebo. And I approached him to supervise me during my special research work at undergraduate level. So I researched on liming of acidic soil that is to be used for growing kale, or sukuma wiki as we call it here in East Africa. Immediately I finished to defend my work. Professor Kalebo was happy with my work and he took my contacts. So he introduced me, even before graduation, he introduced me to the Tropical Soil Biology and Fertility Institute, or SIAT, where I went for my master's. I went for internship. And before I finished the second two contracts of internship, I was able to be funded for master's, and I went to pursue a soil science course at master's level. And the project that funded me for master's, the second phase came up at IITA, the International Institute of Tropical Agriculture. And I got a chance again to be funded for my PhD. And so I did my master's in soil science at Kenyan University of Eldoret. Then I had an opportunity to go to Makerere University in Uganda to pursue my PhD in soil science. And the reason why I have been in this field without changing or getting shaken, it's because agriculture is the mainstay of most households in Kenya, for example. 80% of households rely on agriculture. And I believe that we all understand that. And I also love the introduction that Aaron has given on soil science, that without soil, structures cannot be stable. We cannot have the biodiversity that we look up to. We cannot produce the food that we eat. We cannot extract the derive income or nutrition, even the food security itself. And so agriculture is the mainstay of most households and is the backbone of most economies in this world. And that is why I decided to stay in this course. And I am a happy soil scientist. Thank you, Aaron.
A happy soil scientist. That's fabulous. That's fabulous. Yeah. Great. And it's always noteworthy when someone mentions that to come across an inspiring teacher, because that's often the case. Often the students that we come across who have done these research projects would not have done it, cannot do it without their teachers inspiring them and other professionals offering them assistance in their research. So maybe our student today has a similar experience of teachers and professionals helping in the research. So thanks, Ruth. We'll come back to you after our student to hear about your work in Kenya with your team. And so if I go to our student in Cork in the Christian Brothers College, Nikhil, and by way of introduction, can you tell us a little bit about your experience at the BT Young Scientists? What's a standout memory?
Thanks. This is the first year I went to BT Young Scientist, and obviously I had some experience from it. I was like, I knew people who went to it, and I had the website to look up and stuff, but it's kind of one of those things where you have to be there to experience it, and you don't really get a feel for it unless you're there. My favorite part of it, and like the most exciting part, I'd say, was getting the award on stage. Like you had hundreds of people sitting there with you, all like eager to see whether or not they won. And then when my name was called, it was one of the best experiences I've had in my life so far.
Tell us about that. Which award did you win?
So I got second place in the junior individual category for biological and ecological sciences.
So which year group are you in? Have you won the junior prize?
I'm in second year right now, and it's for first and second years.
Yeah, so fair play. That's very early on to be involved in the BT Young Scientists. So I imagine you maybe have caught the bug. Are you? You're gonna go again?
Yeah, I plan to do it next year as well.
Great. Well, who knows? We might meet you again. I'm sure we will. You've got a few years more ahead of you. to enter the young scientists. That's great. I know you mentioned earlier that you had tried last year as well. So even in your first year, you were attempting. So brilliant, and you got in this time, and you won a prize. So fair play. So the title of it was or is The Fight Against Blight, and you described it for the exhibition in Dublin. This project will aim to investigate the effect of various plant extracts in controlling late blight in potato. If we can bring up the slideshow, Nikhil, maybe you can tell us a bit about why and what you looked into, because some people might be under the impression that potato blight was a 19th century problem and not an issue anymore. Tell us about this challenge for the potato harvest.
Potato blight is caused by the oomycete, which is a organism that's similar to a fungus or fungi, and it's mainly found in like tomatoes, potatoes, and eggplants. So anything in the order Solanae, and it's caused by Phytophthora infestans. I think what like a lot of people would think is, as you said, there was a famine caused by it here in Ireland in the 1800s, and it was like a really major event. But after it ended, the blight itself stuck around, like it didn't completely disappear, and it causes over 10 billion euro in damages every year. One of the main problems we have with blight right now is that we don't have like a 100% complete way to treat it. So what most farmers do if they get blight on their potatoes is they would just remove those potatoes and they would just go to waste. And to prevent blight, they would spray either weekly or bi-weekly with chemical pesticides and fungicides. The problem with those are like right now, for example, we use metalaxyl, and like there have been studies that show that potatoes could or the blight could gain resistance to it in just 1 or 2 seasons, and they're also not the best for the environment.
What's the residue effect of these pesticides?
Metalaxyl and some of the other ones have been shown to have carcinogenic and mutagenic properties, and the WHO said that they will cause damage to the ecosystem, and the mutations will make the food chain unstable. So anything along the food chain that potatoes are in, or just in the general area, will be affected. And then as a result of that, humans are also affected by it.
So the image that we're looking at here, what are we looking at there with the two fields?
This was an image taken by Chagisk, and they took a picture of a field in Carlow that was just newly infected by potato blight. And then 2 weeks later is the same field, and you can just see it's completely destroyed. So it just shows how fast the blight acts, and you really don't have much time once it's infected.
Tell us what you did.
What we did was, it was like an aim to see what the effects of various plant extracts would have on the pathogen. I chose the plant extracts based on other properties that they have. Like, for example, some of them were spices and preservatives. So they would also like naturally have antimicrobial properties to keep the food like edible for longer. Other ones had medicinal properties, and I used them to see if we could kill off the blight using them. So the method we used, we got a sample of the blight from Chagas, and then using that, we grew it on a pea agar. It was a very simple agar, and it was just made using peas and distilled water that we autoclaved with the agar powder. Then we would inoculate them. So the first method we tried to inoculate them was just the swab method. So we'd swab a cotton bud in the already grown plates and then swab it onto the new ones. We tried this, and this didn't work. The Chogsk official that we were speaking to said that it was a really finicky thing to grow, and it's not really, you can't really grow it with traditional methods. So because of this, we couldn't get like a quantitative data set. So we only had like a yes, no, whether or not inhibited or not. We couldn't find percentages, because the way we inoculated it was we would cut out a part of the already grown fungus, including the agar, and then place it in the center of the new plates. And then over time, it was 3 to 4 days, it would grow in 1 to 1 centimeter in diameter. At this point, we would punch out 2 more holes about equal distance from the center on either side. In one of them, we'd put in 50 milligrams distilled water. And in the other one, we had the different extracts. And all the extracts were either essential oils or plants that were ground in water and filtered. We didn't filter sterilize them with the syringes and stuff because at that point we didn't know what the secondary metabolites were that were actually inhibiting the growth. So we didn't want to risk accidentally filtering those out as well. And we also didn't use any antibiotics in the agar as we didn't know how well the blight would grow with them, as it was already quite finicky to grow.
Sounds quite challenging set to experiment with. So, and then how did you choose what you were inoculating it with?
We have previous studies that are on different pathogens. Like I mainly focused on a few that were in potatoes themselves. Like one was on ring rot, another one was on early blight and stuff. So in these, we saw that like different extracts had varying effects. So some of the ones that were already shown to have good effects on similar pathogens were cinnamon, tea tree, thyme, and rosemary. We wanted to see if these would have the same effects on our strain here, which was ungenotyped, so we didn't exactly know what it was. We also chose the rest. We chose the rest of them based on like different properties they had, as I said previously, and we had a wide range of different extracts, so that we didn't just focus on just spices. We had a lot of different things.
And then what results did you get from the different applications?
Results-wise, we had 3 different categories. We had complete inhibition, partial inhibition, and no inhibition. Out of the essential oils, we had cinnamon and dill oils just completely inhibit the growth. So if you could look at the pictures, the white fuzzy stuff in the middle of the plates, that's the blight. And on the left, you can see that around the cinnamon, there's no growth, and it's only growing towards the control. And then on the right, the same with dill. At the top of the right one, there is a little bit of contamination. So that's a shiny colony growing up there. However, we had triplicates on 3 different days that we compared them to make sure that didn't affect the results. These were the ones that partially inhibit. So out of these, the first one is tea tree oil, which was the only other essential oil that had any effect. And we put it under the broad category of partially inhibits, as the other ones are all plant extracts, and they all inhibit like with a small ring. So green chili is, I think, the most obvious one that you can just see. There's like a halo around the actual extract where the fungus doesn't grow, or the umicet, sorry. But tea tree was slightly different in the case that for the first 3 days, so we took results on days 3 and 7, or sorry, 3, 5, and 7. And for the first 3 days, it looked like it was completely inhibiting it. It didn't grow at all. So this was a picture taken on day 3. But then after that, towards day 7, it just grew back. And then we kept the plates for a while longer, and we just saw that it completely grew back, whereas cinnamon didn't grow. It didn't grow at all and just stayed there. So this could be because like the temperature we kept them at, which was 18 degrees Celsius, or just the fact that the essential oil is quite volatile. It could have degraded, or it could have just evaporated or something like that. Okay. The rest are plant extracts, so fennel, green chili, clove, and cardamom. These are ones that partially inhibit, meaning that they have a small halo around it. Some of the other extracts that did not inhibit at all include essential oils, eucalyptus, rosemary, and black pepper. The plant extracts, turmeric, neem, ginger, tamarind, and bitter gourd.
It's interesting how you don't hide the challenges that you faced in your experiments. It's good to showcase the limits of what you could do and had access to. That shows that you've a very thoroughly thought out your procedure. So did you have some recommendations from what you studied as a possible application?
So, like as a next step for this project, we could. So these were all done in the lab with just the fungus on a plate, or the umicet on a plate. So next step would be actually finding infected potatoes and then trying different concentrations of these, as all of these were the same concentration. So we could try different concentrations in live potatoes that are infected to see how well it, A, gets rid of the blight once they're infected, and B, how well it prevents them from getting the blight in the first place.
And is that what you you might explore further? You mentioned that you would like to do the BT Young Scientist again. Are you going to build on this project, or move on to something else?
For next year, I probably won't be doing this, as they start, like most early potatoes would be planted in like March-ish, April. And also I will be away during the summer, so I won't be able to monitor them or actually do the project then.
Right.
The year after, I might continue up on this. If like I had access to the lab in UCC where I did this project, I do have some contacts with like different farmers that said that I could experiment with their potatoes, just a small batch of them. So yeah, in fourth year, I might return to this and expand.
Wonderful. That's great to hear that kind of support from a university and from farmers. That's brilliant. How did you pick this subject or this area of research? How did you come up with or focus on potato blight out of everything you could have chosen?
My grandparents in India, they are farmers themselves, and though they don't farm potatoes, they do like sugarcane coconuts and stuff. But like I know a lot of times like they had a lot of problems, infections, and their plants getting completely destroyed. And they're in a somewhat rural area, so they don't have that much access to facilities to stop that. So if their plants get infected, that's kind of just it. Like that year's harvest is basically ruined. I already knew that I wanted to do something agriculture based, and then I asked them to see if they would have any idea, and they said maybe try something like trying to prevent infections. And then since we're living in Ireland, we were doing the same chapter in history at the moment. Actually, it was the potato blight, so I kind of just stuck to that, and we got the blight off Teagasc, and it kind of just expanded from there.
That's really interesting. That's great. And I wonder just quickly then, because you mentioned India, and so obviously they have access to different plants, and spice varieties, and obviously a completely different culture, traditional background to farming. So something you mentioned, cinnamon being effective. I imagine cinnamon grows in India. Did you get anything from your family of like plant extracts that they do utilize in this way?
Two of them, a little obvious ones. So turmeric and neem. So you basically can't get neem here growing. No. So those two, those are like used in India to stop diseases through plants and animals as well, actually. And they have a lot of antimicrobial and medicinal properties. So I decided to use them as well.
Neem is this kind of wonder plant, isn't it? That is massive, and we've very little awareness of it in Europe. But I know in India, I've been to India, that neem pops up in all sorts of applications. So yeah, brilliant. So thank you. That was a really easily to follow presentation. Thanks a lot. And I know it touches directly on Ruth's work and her team. So if we can move over to Ruth in Nairobi, and we'll bring up your presentation.
Thank you, Aaron. Even as the presentation is being projected, I wanted to make a comment on Nikhil's presentation. I was a bit worried when he mentioned that they didn't use antibiotics in the media or EGA, but I've come to learn that they were working in a very sterile environment, because I didn't see much contamination on those plates. So I want to acknowledge that the work was well done, and just congratulate you for the effort, and wish you the best even as you continue doing your research, and probably recommend that even as you look at plant extracts, you can go ahead and look at biocontrols. For example, Trichoderma species in controlling some of these pathogenic microorganisms in crops. I'll give you an example of what I did at master's level. I was working on tissue culture banana, and I was looking at Fusarium oxysporum as the pathogen. But I also had Trichoderma hasgianum, and I did some work in the lab, quite similar to what you've been doing. We saw the suppressive effect of Trichoderma hasgianum on Fusarium oxysporum. So apart from the plant extracts, you can go ahead and try out the biocontrols, the beneficial microorganisms in the control of these pathogens that are affecting our crops. Thank you.
Thank you.
Yes, my name is Ruth, as I mentioned earlier, and I work for Self-Help Africa. I'm based in Nairobi, Kenya. I work as the Natural Resource Management and Forestry Advisor at global level. At Self-Help Africa, we have many interventions when it comes to agricultural development. And all these interventions contribute to sustainable landscapes, sustainable food systems, and green economy. And some of them are listed in this slide. That is climate smart interventions in relation to crop value chains and animal value chains or livestock. We also promote soil testing and recommendations for fertility amendment, soil fertility amendment. But in this case, we put emphasis on organic amendments or inputs that are friendly to the environment, considering that one of our objectives is to maintain or conserve biodiversity in the environment. We also carry out enterprise diversification. And in this case, when you talk of crop value chains or enterprises, you boosting microbial community restoration. And in this case, you still bring about biodiversity conservation. Soil fertility improvement, for example, when you go into agroforestry, you're integrating crops, food crops, or fodder crops, or trees for different benefits, but some of them are nitrogen fixing, so you're contributing towards soil fertility improvement. And you're also increasing the hosts for different microorganisms, because some of the microorganisms are host specific. Like they can be hosted by specific plants and not others. And also use of manure from livestock value chains in crop production, or manure from plant residue to promote soil fertility management and also boost the general health of the soil. We do value chain development, looking at seed systems development and market systems development or strengthening. I'll give an example of cassava value chain, which is a drought resistant or resilient value chain. And we start from the breeder seed, working closely with the research organizations, regulatory bodies, working with private sector, including the seed entrepreneurs or seed companies, just to develop a stable, reliable, healthy seed system, and also do market linkages to ensure that the produce or the products from a given value chain reach the markets at a good price for the farmers to benefit. We carry out soil and water conservation, especially through farming, during farming, and landscape restoration. There are various soil and water conservation structures that are employed in our work, starting with simple structures like terracing, grass bands, zai pits, stone bands, and just to mention a few. And also landscape restoration, where we do tree growing and management. And by management, I mean farmer managed natural regeneration, that a tree that is growing on its own, probably from a stump whose tree was cut, or seed that was dropped somewhere, or seed that has been dispersed by various means, grows up and the farmer manages it into a mature tree that has various benefits. For example, carbon sequestration, probably giving forth fruits, and that is nutritional income, creating a microclimate in a given farm for the farmer to benefit. We also do biogas production, especially in our dairy projects, where we reduce greenhouse gas emission. We understand that cow dung or animal waste can lead to greenhouse gas emissions. So when this manure is converted into biogas, we can get energy from that, but also reduce the emission of greenhouse gases that cause damage to the ozone layer that contributes to climate change. We are involved in forage-based systems, and in this case, we are lowering the cost of production especially in dairy, whereby we don't just feed animals on concentrates, or we train farmers on feeding their livestock on low-cost forages. For example, we grow desmodium. We encourage farmers to grow desmodium, napier grass, purple vetch, Rhodes grass, cincrass grass, just to mention a few. But in doing this, we also consider the nutritional composition of these given forages. And this brings about a testimony from among our beneficiaries or project participants, where they confess that there is increased milk production at low cost because of the forage-based dairy systems. We involved in watershed management, or generally natural resource management. That is watershed, soil, trees, forests, just to mention a few. And also we train our beneficiaries on the issue of saving culture, developing a saving culture among communities. And from this saving culture, the village savings and loaning associations, they're able to save what they have, or even borrow or obtain loans from the associations, and either use them as a source for their different needs at household level. Some of them pay school fees, some of them clear hospital bills, and some of them reinvest what they get from their savings for future development.
That's quite the list there of programs. Nikhil was mentioning that he wasn't sure about what he might study or research for the next BT Young Scientist. There's quite a list of things there that to pick through and see if there anything interests your curiosity.
Yes, so I just picked a few photos from the many photos from the communities we work with. And the first photo of the group of people, this is a community group, and they are involved in village savings and loaning. So here they're having a meeting. During such meetings, these community members are able to save what they have. They are able to obtain loans and pay a 10% interest. And that money that they borrow, they're able to spend it on various needs. Next photo, where we have the ambassador of Ireland to Kenya. This is a recent photo. I was with the ambassador in the field this last month, and we're visiting a smallholder farmer who is practicing drip irrigation in her kitchen garden. She has obtained the water pond. You can see a water pond lined with a dam liner, where surface runoff is harvested. And this water is used to irrigate the kitchen garden. So in that kitchen garden, that is a newly established crop, vegetables in her farm. And she's adopting various technologies from one of the CBOs, the community-based organization that is promoting these. This community-based organization is working closely with us. It's known as Development Pamoja. And it loans farmers. It doesn't give them like cash, but it gives them inputs. It loans them in form of inputs. So this CBO has loaned this given farmer the water pan or the water pond and the drip kit and even the vegetable seedlings. So this farmer is able to have vegetables from her own kitchen garden. The surplus can be sold to earn some income, and she'll be secure when it comes to food security and income. The first photo in this case, in this slide, shows a tree nursery, a local tree nursery in some county where we are working. And these are seedlings that are either bought by the community themselves, or South Africa buys them and distributes to the beneficiaries of the restoration projects that we are carrying out in 2 counties in the country. Next to it, we have vegetables. This is kale. And this is a very dry part of Baringo County, where we're implementing a resilience project. And these are zai pits. This is a climate smart way of producing vegetables. You dig a pit and you add stones, you remove the soil, add stones, then return organic matter plus manure into the pit and water it adequately before transplanting the seedlings. And in this case, the pit will hold water for long, and this vegetable will live and survive during the dry season. So this is one of the climate smart agriculture practices that we're using for the kitchen gardens in these dry areas. You can compare where the pit is and where the bare part of the ground. No one can even believe that a crop can survive in that area. But because of this given simple technology, the farmers are able to obtain vegetables. Now, the next photo where there is, we have colleagues and some community members holding goats. In the resilience project in Baringo County as well, we supported community groups with dopa rams and some goats and even Sahiwal bulls, just to bring about animal breed improvements. And in this case, some of these, the goats that are being held here are kids that have emanated from the project. I mean, the community has already benefited because the mothers have brought forth these given kids. And the community will keep benefiting because they're using the person approach that once a given household has benefited, the kids are passed on to the next household so that every member of the community group benefits from the output or the products from the project.
But I know you have in your slides, you've picked some information out specifically about potato blight because of the research project. So maybe we can talk about that.
I'm happy with what Nikhil presented. He gave a background on potato blight, and literature shows that it was first recorded in 1840s, that is in Europe, and it quickly spread to most parts of the world. And it mostly attacks the potato family. That is the primary host is the potato, but other solanias crops are also infected. And he mentioned the tomatoes. I would like to mention the nightshade. This is an African leafy vegetable in here that is fed on in Kenya and in other countries, and also capsicum, among other crops that Nikhil mentioned. In Kenya, mostly management of late blights in potato is through a planting certified seed and selection of disease-free tubers. The potato tubers must be stored under cold temperatures just to prevent the growth of the microorganism or the growth of the pathogen. And we also use fungicides at optimal or recommended rates. But of course, we are looking at the residual effect of this or the effect of the fungicide on the environment. And that's why we need to look into other ways of controlling or managing the late blight. Sanitation in storage area, the production area is recommended as a way of managing the late blight. And also, I was referring Nikhil to biocontrols, use of biocontrols. I just mentioned Trichoderma species, but we can also look into other biocontrols, probably the bacillus species or even the mycorrhiza that are beneficial to crop growth. And this came out clearly from Nikhil's presentation, that there are many plants whose extracts can be used for the control of late blight. I've just mentioned a few from the research literature that I came across. And neem was mentioned by Nikhil, eucalyptus, pawpaw, guava, black pepper, you had cloves as well, garlic, onions, cabbage, Mexican marigold. And I would like to say something about onions, cabbage, and Mexican marigold. These are well known, and even some farmers around have been using these like intercropping, either intercropping or using these as for fallowing, just to ensure that organic acids are released to the soils for the suppression of pathogenic microorganisms, not just to mention the pathogen that is causing late blight, but even other pathogens. Because when the organic acids are released through the roots, they suppress. They might not control, but they just suppress the growth or the multiplication of these pathogenic microorganisms. And the extracts are obtained from leaves, fruits, flower buds, and cloves. And some of the chemical composition are as listed: the phenols, flavonoids, alkaloids, just to mention a few. Then the properties: antibacterial, antifungal, insecticidal. I know Nikhil was mentioning antimicrobial, the fighting against the pathogens. Then the two main control mechanisms have been identified. That is through suppression and inhibition. I know Nikhil was talking about inhibition, yeah, and also suppression. And in this case, I would imagine that this happens just because the chemical composition of the extracts is working towards the space that is needed by the microorganism to grow, and also probably making the nutrients not available for uptake by the microorganism or the pathogen. And that's why the suppression comes about, and even the inhibition of growth comes about. I think for Nikhil, I only had all those few slides, but I would like to appreciate the work that he did. It was good work and it's good science. And I know as he progresses, it will give him a good platform even to share with greater people in the science world. Thank you.
No, that was great, Ruth. Nikhil, if you have any response that you would like to make, feel free to come back in. If anything caught your attention, that she covered a lot of information there, but you could see the similarities for what the crops or the plant extracts that you were looking into. So maybe Ruth, just quickly, how big a problem is this right now in Kenya or beyond East Africa, potato blight?
I would say potato blight is the main problem in potato producing areas. And in Kenya, we're talking of the central Kenya and parts of the Rift Valley. I would say that it has been a problem and it is causing issues in potato production because it increases the cost of production because a lot of management measures are to be taken. For example, use of the fungicides that are used in production. But the Potato Association of Kenya has really invested in coming out or encouraging farmers to use disease-free planting materials. And so we also have different organizational companies that are producing disease-free planting material. And also new varieties are being developed just to ensure that farmers are accessing healthy planting materials for this given crop or value chain.
So it continues to be a big challenge for smallholder farmers, for the industry. From my point of view, what caught my ear was this idea of intercropping or planting other crops, even if it's flowers, but it could be actually other valuable crops, such as, I think you mentioned onion, and it was garlic, was it? Or that can actually improve the soil situation or reduce the progress of blight by companion planting. I think that's always very interesting to hear if farmers can have mutually beneficial crops fighting pests. So that could be something, because again, that's very accessible and something that's easily tested and trialed without any expenses particularly, and hopefully not introducing anything new to an area. So thank you both for your participation today. And maybe just before we finish, Nikhil, if I can go back to you briefly, with your experience of the BT Young Scientist so far, would you have any piece of advice for a student that hasn't entered a project yet and is about to or thinking about doing it? What would you recommend that they do for better success?
I would have two main things I would say to them. The first being, enjoy what you're doing. I mean, if you like walk up to BT Young Scientist with a half-hearted project just to get in, you're not really going to do well, because when the rounds of judging come around, you're not going to be that enthusiastic about it, and you'll have information that you don't have backed up and stuff. So if you really have an interest in what you're doing, it's gonna be much better. By yourself, you'll be like more intrigued by things. And then like if you're researching for one thing and you see a little thing, like a little snippet about something else, you'll be like, oh, let me check that out, and then you'll have more and more information. And the second thing is time management. If it's your first time doing it, you should definitely start as early as you can. For the Blight project that I did there, I only started in October or September-ish, and I kind of ran out of time towards the end. Like there are things that you can't control, like if you do something wrong or if there's like a problem at the end, there's not much you can do about it to change it. Whereas if you start much earlier and plan out what you're going to do, then you're going to have a much higher chance of success, as you know what you're going to be doing.
Very good pearls of wisdom. Thanks a lot. So we'll leave our presentation there for today. So thanks very much to the panel, to Ruth and Nikhil, and we will have our Science for Development showcase also in Dublin in early October, and that's where we bring in a select group of projects that we identified at the larger exhibition that really focuses in on the criteria of South of Africa's work and the Science for Development Award. So hopefully, Nikhil, you'll be able to make that event and you'll meet like-minded students there. So thanks very much for your time and for your teacher and school to allow you the time. That's much appreciated. And to Ruth, once again, thank you for being part of the panel. and for that great insight into what's going on with your team. So thank you very much.